we need to put them together. So, Michael, what did you say? How are we going to put those together?
By dividing.
By making it a division problem because the logarithms themselves are being subtracted. Okay, so step one, hopefully you have done this. Is that a plus sign? I think so. You've done this for step one? Now, what's step two? Change it to exponential form. So what would that look like, Madeline?
5 to the second equals x plus 2.
Perfect. And of course, everybody knows 5 to the second is 25. And then we're just going to solve it like any old regular equation, right? So 75 equals x plus 2, and x equals 73. Mr. Strife, what's on that iPad?
Oh, no.
Okay. And we're not journaling, right?
No,
We're paying close attention. Now, we're not done until we go back and make sure in the original problem, not in what my work is, but in the original problem, if I put 73 in, is everything positive that's supposed to be positive? Yep, so we're good. Next, number 2. Problem number 2, another logarithmic equation. How are we going to do that one? Harry? You have thought?
Well, you're definitely going to have to divide. No, multiply.
I'm definitely going to have to multiply, and I'm going to have to multiply because why? Somebody say it.
There's the plus.
There's 2 logarithms. Yeah, well, there's 2 logarithms, which means I have to do something. I'm going to multiply because there's a plus sign there. So I'm going to rewrite that as the log of 2x minus 3 times 6. So I have the log base 3 of 12x minus 18. Is that okay with everybody? Remember, no more than 1 logarithm on each side. So we put those 2 together. All right, now what? This is different than the last one. This looks different. What do I do, Emma?
12x minus 8
Equals what?
2.
Yeah, exactly. Groupies, if you're going to take the logarithm of this, and it's going to equal the logarithm of this, then those 2 things have to be equal. So 12x equals 20, and x equals 20/12, which is what? 5/3? Now go back and make sure when you put 5/3 into the original problem, you got to put it into the original problem, is everything positive that's supposed to be positive? Yes. So we're good. We're good. Number 3 is another equation, but it's not a logarithmic equation, it's an exponential equation. So what do we do with that one? We've practiced this kind too. What do we do?
Put log into it.
What?
Put log or ln into it.
Well, you can absolutely do that because the x is the variable is the exponent. The problem is this is a no calculator exercise. So I really don't want to be taking the logarithm of both sides if I'm not going to have a calculator to type it into. Do you see what I mean? Okay. So if I'm not using my calculator, what's the only other way I can do this problem, Maggie?
To make it so like they both have 3.
They both need a base of 3. Okay? Now, Diana, you had your hand up, so I'm going to call on you. She says we need a base of 3. Does that make sense to you, looking at the numbers that we've got? Okay, what do you want to do with 1/9?
Change it 3 to the negative.
Bingo. 1/9 is 3 to the negative second. Very, very good. Deanna remembers that 1 over means negative exponents. 9 is 3 squared. So she's going to say 3 to the negative second to the x minus 2 equals, Deanna, what's 27? 3 to the third. And it's to the x. Now, what do I do with these exponents? If I have a double exponent like that, what operation do I do? Multiply. So that's going to be negative 2x plus 4. And 3 to the 3x. Now what?
What's the response?
This is just like this one. They're exactly the same. If 3 to this power equals 3 to this power, then the powers have to be equal. Now, we don't have the same negative issue with exponents that we have with logarithms. Is it okay if an exponent turns out to be negative? Can you have negative exponents? Yeah, so you don't have to worry about extraneous roots here. The answer is 4/5, if I did my arithmetic right. Everybody good with that? Okay, number 4. This is another logarithmic equation. What's your thought on this one? Okay, now Julia, there's only one logarithm already, so we're not going to be putting anything together. It's not a matter of multiplying or dividing, right? So what do we do if there's only one logarithm?
We take the off the other side.
No, we can't take just the logarithm of one side. That would not be legal.
Wait,
Think about Madeline's problem that I just erased. Look at problem number 1. When you collected the logarithms, you combined them into one, what did you then do?
oh, I put it into like, two, or like two, you put it like in the different order.
In the different form, yes, and the different form is exponential.
Yeah, excellent.
What is the base on this logarithm right here, Julia? What's the base on this?
E,
So how is that going to translate?
2, or E squared.
E to the second.
Equals 5x.
Now we're solving this equation. We want to know what x equals. So we're going to add 2 and divide by 5. Now don't be uncomfortable with that answer. E is just a number. So don't be uncomfortable with that. That's the answer. And if you had a calculator, you could type that in and get a decimal. But we don't have a calculator, so we're just going to leave it like this. Uh-oh, number 5, I'm not even going to write anything down. I've been paying attention in class, so I know number 5, the answer is 4. 10 to the log base 10 of 4 is 4. That's a property. Actually, 6 is a property too. What do you think the answer to 6 is?
4.
It's 2 because ln e means log base e of e to the first. So ln e is just 1. When you put a 2 out in front of it, then it becomes 2. Or you could think of that 2 as an exponent, right? That's what it is. Coefficients are coefficients in front of logarithms are exponents. So this is ln e squared, which is log base e of e squared, which is 2. How about number 7? 4. Same exact problem, only the base is 10. The log base 10 of 10 is 1 times 4. How about 8?
1.
It's 1. Very good. And that problem doesn't need to be confusing. Because what does this 3 become? What is that 3? It's a coefficient, so what do I do with it? So if I make that an exponent, I have the cube root cubed. What's that? What's the cube root cubed? Just e to the first? And the log base e of e to the first is 1. 9. Remember, with this kind of stuff, you can do things in whatever order makes sense to you. So, Katie Swanton, what makes sense to you to start? There is no single right answer. You can start any way you want. So what?
Flip it to get rid of the
We can flip the whole thing to get rid of this.
Yeah.
Now, I'm going to flip the entire thing And that's gonna make my, make my exponent positive 2/3. All right, Anna, what occurs to you to do next? You got a negative exponent within the fraction itself, so he's gonna go to the bottom. Now you already have 2 of them down there, Anna, so when I bring that one down, I'll have 3. All right, Carter, what are we gonna do next? We've really pretty much done everything, so there's only one thing left to do. Carter. That's all, that's secure the exponent, that's right. So what's 8 to the 2/3 mean, Carter? Uh-oh, he can't remember. Does anybody remember what 8 to the 2/3 means, Delaney?
It's the third root of 8.
Yeah, Carter, that's a biggie. Okay, so write that down somewhere, put a star next to it. 8 to the 2/3 means the cube root of 8 squared. Fractional exponents mean radicals. Fractional exponents mean radicals. Okay? So what's the cube root of 8?
2.
Squared? So my numerator is going to be 4. Now I got to do the same thing with the 27. So Carter, redeem yourself. 27 to the 2/3. What's that going to be? Okay, let's look up here. What did we say 8 to the 2/3 meant? Well, the cube root of 27 is 3, but then you have to square it. Okay, I need you to look up here. Cube root of 8 squared. Cube root of 8, 2 squared 4. That's how we got 4. Now do the same thing with the 27. So it'll be the cube root of 27, 3 squared 9. Got it? I can't, Carter, you're staring at me blankly. Is there a part of that you don't understand? What part of that do you not understand?
I actually wrote it off. I wrote, square root of, 27 cubed.
Okay, it means the cube root. The denominator tells us which root to take, okay? Fractional exponents mean radicals. The denominator is the root. Okay? Now we have the same thing here. But these are variables now, so we're going to raise, we have another double exponent. So what did we say we did to these when we have a double exponent? Multiply. So that's going to be x to the second and y to the 2/3. Now, this is a problem that I don't know if we have encountered. I know you have in your previous life, but I don't remember if we've hit this or not. Let's look at this for a minute. Can anybody tell me what's the matter with this? Why do I not just put a circle around it and be done? You can't have a radical in the denominator, right? That's a rule you are very familiar with. You cannot have a radical in the denominator. Does this problem have a radical in the denominator? It does. So we need to get rid of that, okay? How are we going to get rid of that? Well, do you remember, let's just back up. Back in the old days when you were little kids and you had a problem like this. And to get rid of that, what did you do? You multiplied top and bottom by the square root of x. And the reason that you did that was so that when you times these together, you got a plain x. Right, that's your goal. So I want you to look at this one. Clearly, I'm going to have to multiply the top and the bottom by some y so that instead of having a fraction down there, I have a whole y. I need a whole y in the bottom. Now, how much of a y do I have right now? How much am I going to have to multiply by in order to have a whole y down there? 1/3. Because when I multiply y to the 2/3 times y to the 1/3, I get y to the 3/3, which is 1. There's the answer to the question. Now, this is the correct answer. It just is not in good form because it has a radical down there. So we have to get rid of that radical by filling in the rest of the y. So if we would have had a problem like this, let's say we had 8x over 5zy to the 5/7. Let's say we did some problem and we ended up with this. You can't have that in the bottom. Why? Because it's a radical. So it's only a fraction of a y. We need a whole y down there. So how much more am I going to have to multiply by to fill in what's missing? 2/7? And that would make then the whole y. And then the top is just whatever the top is. Okay? Number 10, how are you going to do that? No calculator now. How are we going to do problem number 10? What's your idea? Make it equal x. Very good, Madeline. And what good would that do me then? Just to set it equal to x. What now can I do?
Change it to 2, like the basis to 2.
You know what? I could have done that. It's really hard to change that base right there of the logarithm.
Oh,
So
wait, no, 4 to the x.
yeah, let's do that first, and then, Madeline, do what you said. So she says, let's rewrite the logarithmic equation in its exponential form. Julia, this is what you were struggling with earlier. This would be 4 to the x equals 8, right? Now, look, no calculator allowed. You got a 4 and an 8. O'Malley, get your head up. What makes sense if we have a 4 and an 8?
2.
Change them to 2. So 2 to the 2x equals 2 cubed, which means 2x equals 3, which means x equals 3/2. We okay with that? Okay, tomorrow we're going to have a little quizzy poo, and it's going to have these kinds of problems on it, as well as a word problem. And the word problem it's going to have on it is going to use one of the formulas that you are required to have memorized. So, does anybody have those memorized now? You have to have them memorized by tomorrow. One of them is this one. And this is the one, if your problem, if the problem that's given to you is some kind of nature problem, or if it says interest is compounded continuously. This is the formula you use for any kind of continuous growth. All right, so let's practice one of these. Let's suppose I have, let's see, right now in my Petri dish, I have 5, 6, 7, 8 bacteria. In 6 hours, I'll have 1, 2, 3, 4, 5 bacteria. Find the growth constant. Now, in a money problem, the growth constant is referred to as the interest rate. So it's like a percentage, right? It's like a decimal. All right, does everybody understand this problem would use that formula? All right, let's practice using it. What goes where in the formula? Got all those letters there. What goes where?
5, 6, 7, 8 is P.
Okay, so 5, 6, 7, 8 is P. 1, 2, 3, 4, 5's A. It's on the other side. Because remember, in the formula, this is what you start with, and this is what you end with. This is the start, this is the end. Okay, now what?
6 is T.
6 is T, and R is what I'm looking for? Okay, now we gotta solve it. This will be a calculator problem. If I want an answer, I may just have you show me how you would solve it. Doesn't matter. What's gotta be step 1? Divide. So you're gonna have 1, 2, 3, 4, 5 divided by 5, 6, 7, 8 equal to e to the 6r. What's next? Natural log both sides. Kids, where is the variable? Exponent. When that happens, unless you have a common base, no chance, you're going to have to use logarithms. So we'll ln both sides. What happens when I ln e to the 6r power? It just equals 6r. We got to stop being confused by that. This is log base e of e to a power. The log base e of e to a power is the power. That's one of your properties. And then we'll divide by 6. So that would be the answer. So if I don't let you have a calculator for this at all, then you'll have to stop right here, right? If we do have a calculator, then we can type that in, making sure we close the parentheses here. And I got 0.1294. Did you? Anybody match that? Can you tell me what that means? Can you translate that for me? What does that mean?
Every hour it grows by 0.1294.
Or in other words, it's almost a 13% growth every hour. So the population is increasing almost 13% an hour. You good on that one? Okay, what's the other formula? There's 2 formulas, and you're only going to have one word problem on tomorrow's quiz. You don't know which one it is, though. So you got to know both formulas. That's one of them. Yep, that's the other one. And an example of this might be, Emma Vila, you working on math back there? An example of this might be, how much would I have to invest at, let's say 3.5% compounded monthly to have, I don't know how much you want to have, $3,000 after 5 years. Now, what in that problem clues you in that that's the formula you're using and not this one? One word or 2 words. Compounded monthly. Because if you're using this formula, you are not compounded monthly, quarterly, daily, anything. You're compounded continuously in this formula. So if I changed one word, if I changed this to continuously, you'd be using that formula. Any other compounding, it's going to be this formula. Okay, so what goes where? In terms of solving this, what am I going to put in where? 3,000 is A. P is my unknown, isn't it?
Yeah.
That's a 1. Interest rate,
0.0.
0.035, perfect. You cannot put it in as the percent, you have to put it in as the decimal. Divided by 12, raised to, and that's 12 because monthly, raised to the 12 times 5 power, or the 60th power. Now, are we going to need logarithms to solve this equation? Absolutely not, because when do we need logarithms? When the variable is the exponent. So if I were looking for this, I'd be using logarithms, but I'm not. This is plain and simply a division problem. Don't I need to figure out what this is and then divide it over here under 3,000? So I'm going to type that into my calculator. Now again, tomorrow, I haven't written this quiz yet, so I don't know what I'm going to do. But if I don't give you a calculator, then I may just have you set it up. So you set up. If you have a calculator, then you're going to take 1 plus 0.035 divided by 12. Okay, and then raise that to the 60th power. And then do 3,000 divided by that number. And remember, you have an answer button. So if you just do 3,000 divided by answer, just down here on your negative sign, you don't have to retype and round off. I got 2519.01. What about you? So a little more than $2,500 investment is what it would require for you to end up with $3,000. Okay? Okay, all right, so quiz tomorrow. Somebody remember, we still have to do that challenge part. I want to go over your homework, and I want to look at a couple more word problems today. So we'll pause on that review for a second, and we'll look at our homework. Anybody have a question about a homework problem? Get to the right page here. All right, here I am. Who had a question? Maggie?
Could you give me the 30 to 31?
Oh, these are the tricky ones. Yes, indeed. We need to look at these. These are not on your quiz tomorrow. However, could be on next week's test. So let's see what we've got with number 30. Okay, this is tough. This is tough. Here we go. Step 1. Let's get rid of that. So we have 2 to the x plus 2 to the negative x equal to 6. Is that okay with everybody? What does that mean? 1 over. So we have 2 to the x plus 1 over 2 to the x equal to 6. So far I'm just kind of trying to take care of business. I don't like this fraction here, so I'll get rid of that. Don't care for negative exponents, so I'll get rid of that. But as soon as I do that, now I've got another fraction. So now I'm going to multiply everything by 2 to the x. So I'm going to have 2 to the x times 2 to the x plus 1 equals 6 times 2 to the x. Just clearing out that fraction. Is there another way to write this? Be careful. What do I do with these exponents? It's not a double exponent, so you don't multiply them, you add them. So that would be 2 to the 2x. Minus 6 times 2 to the x plus 1 equals 0. I'm just getting a 0, so I'm going to subtract this over. By the way, the 6 and the 2 cannot be combined. This is like an exponential expression, like a and b. They can't be combined because that one has an exponent. Just got to leave it like that. this, here comes, this is where it gets tricky now. This is the same as this. Would you agree with that? So what I have here is an equation that's the format something squared minus 6 of those things plus 1. It's something squared minus 6 of those things plus 1. So I might think of it as an equation of that form. Letting A be 2 to the x. This is too confusing for me, but this is easy. I know how to solve this, right? How do I solve this? If it factors, I factor it. I don't think this would factor, so I will use my quadratic formula. Now I'm going to solve this equation, which groupies is exactly the same as this equation, except instead of having this ugly 2 to the x, I took it out and said I'm just going to put in A. So A equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's 6 plus or minus the square root of 32. Which is 6 plus or minus 4 root 2. Which is 3 plus or minus 2 root 2 if I cancel. Let me back up. So A equals 3 plus 2 root 2, or A equals 3 minus 2 root 2. So far so good? It's confusing, I know, they're hard. Let's get decimals for that, because we are not done. We are not done. Let's get decimals for it, and then I'm going to have you tell me how come we're not done. I got 5.8284 for that one. I'm going to have you double check. And 0.1716 for that one. Now, why am I not done? That says A equals that. Because there wasn't an A in my original problem, right? Where does A come from? What did I say A was? 2 to the x. So now I've got 2 to the x equals 5.8284, or 2 to the x equals 0.1716. Because my original variable wasn't A. My original variable was 2 to the x. How do I solve that? Can't do that. I have to take the logarithm of both sides. I'm going to have to take the logarithm of both sides of that. This is a big problem. So I've got 2 to the x equals 5.8284. So I'll take the logarithm of both sides. And the exponent comes off. And finally, after all that messing around, I'll have the log of 5.8284 divided by the log of 2. And that's half my answer. I got 2.548 basically. I know this is hard. We gotta, hopefully you're paying attention, trying to follow along. Why do I say this is only half the answer? because now I've got this one to do. Do that one on your own. Do it exactly the same way. Tell me what you get as your answer when you do that one. Negative 2.54 something. Now, I don't want you to panic. Remember, this was our, well, I erased the original problem, but it was some version of this. Where is x? X is an exponent. Is it okay to have negative exponents? Well, not in your final answer, but is it, can you have, do negative exponents exist? Yes. So this is not a case where you're going to cross it out and say it can't work. That's only when you're taking the logarithm of it. This is an exponent. So your other answer is fine. Negative 2.543 would be fine. Absolutely, those are tough problems. I get it. I get it. Those are tough problems.
So for 31, would it basically be the syntax?
I'm going to do 31 after I hand out. O'Malley?
Yep.
And who are my other football players? Are you my only football player in here?
We got a trainer too.
Okay, okay. All right, well, for football players, I heard your name on the announcements, actually.
Heard twice.
Twice?
Twice.
So here's some, if you want some banana bread, have a piece of banana bread there in honor of our football team's regional championship. And while you're doing that, let's look at that last problem that Maggie asked about, because it's the same kind of thing. So let's see if we can work our way through it. Which number was it, Maggie? 31. Okay, this is number 31. Does it look at all familiar? Yeah, what was the last one I did, 30? Yeah. This is 31. All right, here we go. So let's see if we can remember. Step 1, what did we do last time? Multiply by 2. Okay. Step 2, what did we do last time? 1 over. So e to the x plus 1 over e to the x equals 8. Everybody okay so far? Step 3 is easy. Multiply by e to the x because we've got another fraction to deal with. Now this is where things start getting a little bit hairy. You've got to recognize, what is that?
2.
E to the 2x plus 1 equals 8e to the x. Then you've got to recognize that this is the same as e to the x squared. If you just write the exponent backwards, minus 8e to the x plus 1 equals 0. Getting the equation set equal to 0, move that over. Okay, you with me? This is exactly the same as the last time, right? Now, this is hard to work with. If I say I'm going to let a equal e to the x, can you see where you have a squared minus 8a plus 1? Can you see that? Can you solve this equation? Forget that for a minute. Can you solve this one? Yes. It doesn't factor, so we'll say a equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? So what does a equal? 8 plus or minus the square root of 60 over 2? Now, the last time I did this, I simplified all this, remember? I broke it all down. Was that really necessary? No, because where am I going next with this? to my calculator. So at this point, you recognize, if you want to simplify that, go ahead. But we're eventually just gonna put it into our calculator. So this time, I'm just gonna leave it 8 plus root 60 over 2 and 8 minus root 60 over 2. Those are my two answers for A. So I can get those decimals, you can get those decimals. We can all get those decimals. 7.8730. I'm counting on you correcting me if I'm wrong. And 0.1270. Now we are basically half done with the problem. These are not the answers. These are the values for A, which is the letter I plugged in to make my life easier. What do I have to do now? Go back and remember that the A's were really e to the x's. And now I have two new equations to solve by ln'ing both sides. So since this is log base e of e to the x, that's just x, that's just one of my answers. And then the other is going to turn out to be the same thing. So I got 2.06, 3, and negative 0.2064. Do you match those? This is not on tomorrow's quiz. Tomorrow's quiz is going to be what we practiced at the beginning, along with one word problem, so you have to have your formulas memorized. Okay, everybody clear on that? Well, of course you gotta know the properties in order to do the equation. Now, remember that a week from today your paper is due. Some of you have turned them in early. I love you people.
What's it over?
Get on the website and look it up.
Our test is, it's over ourselves.
Our test is either going to be Monday or Tuesday next week. Our test will be either Monday or Tuesday of next week. Plan accordingly.
We got